We're going to do some practice problems here with percent composition and the breakdown of some various compounds that we're going to look at. First one here, we're going to look at copper sulfide. So I'm going to have my copper sulfide there. I'm going to work out its total gram molecular mass. So 2 times the mass of copper plus 1 times the mass of sulfur. That's going to work out to be 159.16 grams per mole. Now I'm going to take each one of these and multiply by how many there are. There's 1 sulfur in there, so I'm going to take that, multiply it by 1. And there's 2 copper, so I'm going to multiply that by 2. So what I'm left with for copper is 127.1. Well, I'm going to take that and divide that by the total mass of copper 1 sulfide. So 127.1 divided by 159.16 times 100 is going to give me 79.86%. That is the percentage that it is taking up in that particular compound. Sulfur, same idea there. I'm going to divide by the same number, multiply by 100, and I'm going to get 20.14%. Ideally, when you're doing a percent composition, these numbers here should add up to 100%. Whenever you're doing composition, they should always add up to 100%, and these ones do. Now let's take a look at lead chloride. So 1 times 207.2 plus 2 times 35.45 is going to work out to be my total mass of 278.1 grams per mole. As I did before, I'm going to multiply these by how many we have. We have 1 lead, so that's 207.2 as it was already, and we have 2 chlorine, so I'm going to multiply 35.45 times 2. That's going to work out to be 70.9. Divide that by my total mass, multiply it by 100, and I'm going to get my percentages here. So lead is going to work out to be 74.51%, and chlorine is going to be 25.49% of the total mass there. Again, they add up to 100. All right, percent composition of barium nitrate, as I've done before, I'm going to find the total molecular mass. I'm going to take each one of these and multiply them by how many there are. There's 1 barium, there's 2 nitrogen, and there's 6 oxygens. Doing all that, dividing by the total amount, multiplying it by 100, and I'm going to get for this top one 52.55, 10.72, and 36.74. And if you do it all right, this should have to add up to 100. Mine adds up to about 100.01, but we're going to kind of ignore that last one there. You did some rounding errors in there. So again, when you do percent composition, the final amount will always be 100%. Now this one I'm going to be looking at the mass of water in a hydrate. Now what I need to do here for this one, for my total calculations, I need to factor in the fact that I'm going to have 4 oxygens here and 7 oxygens from the water in the hydrate there, because I still need to get the total amount. Hydrogens, that one's also going to be a little bit tricky, but I need to factor in that it's 7 times 2, so I'm going to have 14 there. So this is my zinc, that's my sulfur, that's my oxygen, that's my hydrogen. Total mass 287.58. The water, if I'm just looking at that, water is going to be 18.02, and I have 7 of them, so that's going to work out to be 126.14. That is the mass of the water in there. Now I'm going to divide that by the total mass, because I'm looking at the total amount there, multiply it by 100, and water is making up 43.86% of this particular hydrate. All right, last one, I'm using this percentage now, so I'm saying that oxygen is 54.87% biomass of this particular compound. Now, I have all this extra information. With the exception of oxygen, I don't really need that. So I'm going to take my 175 grams, and I'm going to figure out what 54.87% of that is. So that's just multiplying it by 0.5487. It's 54.87 divided by 100, and I get 96.02 grams of oxygen. Now, they're asking how many moles of oxygen are that. So I'm going to do my conversion for this, canceling out grams of oxygen. What I'm left with is 6.00 moles of oxygen. That is what is found in this particular compound.